Astronomers have discovered the second closest black hole to Earth, Gaia BH3. However, this black hole is about 3.5 times larger than the closest known black hole to date. This massive size places it in the category of black holes that shouldn't exist. So, how did we miss this giant black hole right under our noses for all these years? And more importantly, what other unknown black holes are lurking out there in the dark, hidden from us? Perhaps the universe is a labyrinth waiting for us to unravel its secrets. Let's explore this mystery together. This impressive discovery is not the work of NASA but rather the European Space Agency, ESA, achieved by the Gaia Space Telescope, which was launched in 2013. Like the famous James Webb Space Telescope, Gaia also orbits the special gravitational region called the L2 Lagrange point. This is one of 5 unique areas formed by the gravitational interaction between the Sun and Earth. The L2 point is located about 1.5 million kilometers away from Earth, on the side opposite the Sun, along an imaginary line connecting the Sun and Earth. Since its mission began, Gaia has achieved incredible feats. For example, it has successfully cataloged 1.7 billion out of the approximately 400 billion stars in the Milky Way galaxy with high precision. Moreover, we continue to discover new exoplanets, galaxies, and stars every year. Astronomers typically prefer to release this vast amount of data in catalogs every 3 to 4 years rather than publishing individual findings. Gaia's latest data catalog was released in 2022, and the next one is expected in 2025. However, the discovery of the black hole named Gaia BH3 is so remarkable that astronomers chose to publish a paper focused solely on this finding instead of waiting for the next catalog release. Despite its unusually large size, Gaia BH3 is not a supermassive black hole, it is a stellar black hole. Still, it stands out as one of the largest stellar black holes ever observed, making it exceptionally special. This black hole could be just the beginning of the secrets hidden in the depths of the universe. So, what else is out there? Are we ready to lift the dark veils of the cosmos and uncover its mysteries? Stars with a mass 8 times greater than our Sun or more, when they reach the end of their lives, exhaust their fuel and end in an extraordinary explosion called a supernova. During this process, the star scatters a significant portion of the matter and energy that formed it into space. However, the remaining material is compressed so intensely during the explosion that an incredible mass is concentrated into a very small volume. If this material exceeds the Tolman-Oppenheimer-Fokoff limit, known to be around 20 to 30 solar masses, the star's core continues to collapse inward and transforms into a black hole. If it falls below this limit, the star becomes a neutron star. A lesser-known fact is that for a star to turn into a black hole, it must not only have a minimum mass but also a maximum mass. If the dying star is extremely massive and rich in metals, containing atoms heavier than hydrogen and helium, powerful stellar winds form around it. These winds cause gases to escape from the star's atmosphere into space at high speeds. Just as Earth's atmosphere determines its fate, the activity in a star's atmosphere can also shape its end. These massive stars lose so much mass by the end of their lives that they weaken their supernova explosions and may not turn into black holes. Additionally, in stars 130 to 250 times more massive than the Sun, a rare event called parent stability supernova can occur. In the cores of these extremely large stars, thermal photons transform into electron-positron pairs, destabilizing the core. As a result, these stars experience such catastrophic explosions that nothing remains to form a black hole. For this reason, we thought that stellar black holes could have a maximum mass of around 20 solar masses and assumed anything larger was impossible. However, the newly discovered Gaia BH3 has turned these assumptions upside down. With a mass of 32.7 solar masses, this black hole seems like an object that shouldn't exist. Moreover, this isn't the first abnormally large stellar black hole we've discovered. So, what other surprises might the universe be hiding from us? If you recall, The biggest science news of 2015 was the detection of gravitational waves by the LIGO interferometer, resulting from the merger of two black holes. This was indeed one of the most spectacular confirmations of Einstein's theory of general relativity. However, there was a critical detail about this groundbreaking discovery that wasn't emphasized enough: the masses of the merging black holes. One was 29 solar masses, and the other was 36 solar masses. If you notice, these values were well beyond the 20 solar mass limit we had predicted for stellar black holes. Although earlier examples like Cygnus X1, with a mass of 21 solar masses, had hinted at this possibility, black holes of that size didn't seriously challenge the theoretical limit, so they didn't pose a major problem for existing theories. However, LIGO's 2015 findings provided a much clearer indication that there might be another phenomenon at play behind this. This discovery, which showed us that we might still be at the very beginning of understanding black holes in the universe, lifted the veil of mystery surrounding black holes a little further. Who knows what other secrets are still hidden? Understanding exactly how stellar black holes form is crucial for solving one of the universe's greatest mysteries. From fictional examples like Gargantua in the movie Interstellar to real-world supermassive black holes like Sagittarius A** at the center of our Milky Way galaxy, we still know very little about the origins of these massive structures. These supermassive black holes are not 20 to 30 times the mass of the Sun. For example, Sagittarius A** is approximately 4 million solar masses. Similar structures in other galaxies can reach billions of solar masses. It is thought that black holes of this size likely formed initially from the direct collapse of massive, metal-poor stars. These stars, being less affected by stellar winds and potentially collapsing without even experiencing a supernova explosion, could have formed at enormous sizes from the very beginning. Over billions of years, they may have grown to incredible sizes by merging with other black holes and consuming surrounding matter. However, these processes are still not fully understood, and research is ongoing. Perhaps the story of supermassive black holes will become clearer once we fully unravel the secrets of stellar black holes. So, when will we completely solve the mysteries of these colossal structures? Maybe we are still at the very beginning of lifting the dark veils of the universe. Today's focus, Gaia Black Hole 3, or simply Gaia BH3, may not be a supermassive black hole, but it is a discovery just as astonishing. This stellar black hole, approximately 33 times more massive than the Sun, is located only 1,930 light-years away from us. The fact that we have only now discovered such a massive black hole at such a relatively close distance in astronomical terms is proof of how many mysteries the universe still holds. Let's be clear, 1,930 light-years is still an enormous distance. It's only about 2% of the distance from one end of the Milky Way galaxy to the other. So, the chance of waking up one morning and finding ourselves face-to-face with Gaia BH3 is practically zero. Even if we could travel at the speed of light, it would take us about 1,000 years to reach this giant black hole. However, when discussing astronomical risks, it's important to understand that the scale of time and distance involved in such events far exceeds our everyday imagination. Compared to other risks in our lives, we can confidently say that Gaia BH3 does not pose a significant threat. Nevertheless, the discovery of this black hole is of incredible astronomical importance. For context, consider Gaia BH1, another black hole discovered by the Gaia Space Telescope, which is 9.5 times the mass of the Sun and located just 1,560 light-years away. This shows that these distances should not be underestimated. BH3 is now the second closest known black hole to us. What other black holes might be hiding in our galactic backyard, still unnoticed? Who knows, perhaps this mystery will open the door to uncovering other secrets of the universe. The discovery of unusual black holes like Gaia BH3 is helping us better understand how stars much larger than 20 solar masses can transform into stellar black holes. One of the factors enabling this transformation is stellar metallicity, the proportion of atoms heavier than hydrogen and helium. Metal-poor stars, due to their low metallicity, are less affected by stellar winds and can retain more of their mass. Additionally, interactions between stars before their death can also shape the characteristics of the resulting black hole. For example, in binary star systems, one star can strip away the outer layers of its companion. This process can allow stars that would normally not form a stellar black hole to reach such sizes. Interestingly, Gaia BH3 is part of such a binary system. Its companion is a red giant star, known to be extremely metal-poor, large, and bright. With its dynamic structure, Gaia BH3 continues to be a mysterious corner of the universe, offering us deeper insights into the formation and evolution of black holes. Who knows what other clues such discoveries will provide as we lift the veil of mystery surrounding black holes? What allows us to detect black holes like Gaia BH3 is actually their companions. Black holes themselves are nearly invisible in the dark void of space because they emit no light, except for possible Hawking radiation. Therefore, to find black holes, we look for anomalies in the orbits of bright stars around them. If a star appears to be orbiting something we cannot see, we infer the presence of a black hole. By analyzing deviations in the star's trajectory, we calculate the black hole's mass and confirm its existence using gravitational lensing observations. For example, the star orbiting Gaia BH3 completes one orbit around the black hole every 11.6 years. Interestingly, this star does not appear to be contaminated by material ejected from a recent supernova. Additionally, Gaia BH3 has no accretion disk, a ring of matter being pulled in by the black hole's gravity. These factors are among the reasons why we discovered this black hole so late. Moreover, this black hole likely formed long before it captured its companion star. One day, Gaia BH3 may devour its companion. However, what makes this discovery even more intriguing is that the companion star formed no more than 2 billion years after the Big Bang. This means Gaia BH3 must have formed even earlier. Although our Milky Way galaxy formed a few 100 million years after the Big Bang, it wouldn't be wrong to say that this black hole witnessed the infancy of our galaxy. But things take an unexpected turn here. The star in the Gaia BH3 system moves in the opposite direction compared to most stars in the Milky Way's central disk. Combining its ancient age and retrograde motion, we conclude that this binary system likely did not form within the Milky Way but instead came from another galaxy. In other words, Gaia BH3, the second closest known black hole to us, might be a space alien on a galactic scale, a traveler from another galaxy. This isn't entirely surprising. We already know that the Milky Way has collided with many neighboring galaxies throughout its history. For instance, between 11 and 8 billion years ago, an event called the Gaia Sausage Merger occurred. During this event, a dwarf galaxy known as the Gaia Sausage collided with the Milky Way, causing many stars to join our galaxy. If you're wondering about the name, it comes from the fact that the velocity graphs of these stars resemble a sausage shape, discovered thanks to the Gaia mission. Perhaps Gaia BH3 was brought to our galaxy through this merger and, by chance, settled into a relatively close orbit to us. What we know is still very new, but we are eager to learn more about this black hole in the coming years. Meanwhile, it's estimated that there are over 100 million black holes in the Milky Way alone, and we've only discovered a tiny fraction of them. If we want to ensure the long-term stability of our solar system, we need to better understand the black holes around us.